Hello everyone, this is Heading 10. In this video, let's learn the chapter 5.4 Trigonometric functions defined on the unit circle. And first, let's introduce what is the unit circle. Unit circle, that means a circle with the radius 1. So from the center to here, the r equals 1. If we place this unit circle to the xy coordinate plane, so I draw it on the xy plane. Here is 1, here is -1, here is -1, here is 1. So each point on this unit circle, the point is x, y, need to satisfy that x squared plus y squared equals 1. So that's the unit circle. If I give you a point which is a -1/2 and square root of 3/2, does this point on the unit circle, if it satisfied this equation, that means this point is on the unit circle. Let's try. So -1/2 squared plus square root of 3/2 squared. Is this one equals 1? Let's see. So the negative numbers squared make it into a positive number. So this is 1/4 plus square root of 3 squared, that's 3/2 squared, that's 4. This one is 1. So this point is on the unit circle. What's the relationship between the trig and the unit circle? Let's clean up this place. So if I have a right triangle, A, B, C, and this leg is A, this one is B. This angle is theta, and here is C. Let's C equals 1. And I place this right triangle on the unit circle. And you see that this is A, this is B, corresponding to the point here, A, B here. And also we have learned that the Pythagorean theorem that A squared plus B squared equals C squared in this right triangle equals 1. So that satisfied the equation x squared plus y squared equals 1. That means A is x, B is y, and this point is on the unit circle. So I can use x, y represent A, B. So here can be y, and here is x, because the distance from here to here, that's A, that's x. And the distance from here, that means the y's value, that's B. So A is x, B is y. So we just place this in the xy coordinate plane. Then it will help us to compute easily. And let's see here. In this triangle, in the right triangle here, this right triangle, and this is theta here. So what is cosine theta? Cosine theta equals adjacent over hypotenuse. Adjacent is x, hypotenuse is r, r is a radius, that's 1, so that's x. What is sine theta? Sine theta equals opposite over hypotenuse, which is y over r. R is 1, so this is y. That means the x and y, I mean the point, can be represented by the cosine and sine. So the x value is, the x value can be written like cosine theta, and y's value can be written like sine theta. So if they gave us, given that theta equals pi over 4, so find the point. So we can have cosine pi over 4, sine pi over 4. That is square root of 2 over 2, square root of 2 over 2. So if they gave us the angle, and then we can find the point. Let's move on. Here is the summary. Unit circle definition of trig functions. Let's the point P be the point associated with a real number t, measure along the circumference of the unit circle from the point 1, 0. So why they provide us the t, the arc length, not the angle? Because we mentioned about the angle theta here. Since this is the unit circle, if I want to find the arc length, so we have learned the formula arc length S equals R times theta. And here they said the arc length is T. So T, we plug in the T. And then R is 1. That means 1 times theta. That's theta. So we learned that T is theta. So here, if we said with a real number T measured along the circumference, that means they provide us the angle in the radians form. So if T equals theta, we have learned that sine theta equals y, cosine theta equals x. So sine t equals y, cosine t equals x, and their reciprocals are cosecant t equals 1 over y, secant t is 1 over x, tangent t. So we have learned that tangent equals sine over cosine. And we have the sine and cosine, which is y over x. So tangent t equals y over x. Cotangent is the reciprocal of tangent t. That's x over y. And we have learned that if we have a fraction a over b, if b equals 0, so this expression is undefined. Undefined. And look at our expression here. The y appears in the bottom for the cosecant t. So if y equals 0, the cosecant is undefined. So we can't choose y equals 0 for the cosecant. For the secant, y is in the denominator, I mean in the bottom. That means it's undefined if x equals 0. And for cotangent and the tangent, they are the same. So don't let the x equal 0. Otherwise, the tangent t will be undefined. And we can't choose y equals 0 because cotangent will be undefined. Let's continue. See this example. Suppose that the real number t corresponds to the point this on the unit circle. Evaluate the 6 trig functions of t. So we have learned that if they give us the point, and we will know that first one is cosine t, second one is sine t, Sine t equals y's value, and we have this. Cosecant t is a reciprocal of sine, so just find the reciprocal of this. Equals, keep the negative sign, and 3 goes up, and square root of 5 goes top, because just flip this. And then rationalize this, we have 3 times square root of 5 over 5. And cosine t, that's the x value. So that's negative 2 over 3. And the secant t is 1 over x, that's negative 3 over 2. Tangent equal y over x, that's equals, use the y's value divided by x value, and we have square root of 5 over 2. And cotangent t, that's a reciprocal of this. So 2 goes to the top, and the square root of 2, square root of 5 is in the denominator. We have 2 times square root of 5 over 5. Okay, let's see next part 2. Part 2, evaluate the trig functions using the unit circle. First part, it shows us y t equals theta. We talked about this before. Since s, the formula for the arc length, s equals r times theta. If the arc length is t, and our r, the radius, is 1, so t equals 1 times theta, that means t equals theta. This is for the positive angle, because you see it's going the counterclockwise direction. How about the negative angle? If arc length is negative t, the radius is 1, and plug it in the formula, because this is going to the clockwise direction. The theta must be, the angle must be a negative angle. So plug it in the formula. We got t over equals theta. That means t equals theta. Even t, we know this is arc length, and theta is the angle, but they have the same value. Okay, here shows you 6 trig functions. Since theta equals t radians, so sine t equals sine theta, cosine t equal cosine theta. So you just read this table, pause the video and read the table. Let's see next one. If they provide us an angle theta, if they say theta equals 3 pi over 3, I can also say that's 60 degrees. Can you find the point? For sure, because the point is cosine theta, sine theta, and plug in the theta, that's cosine pi over 3, sine pi over 3. And we know cosine pi over 3 is 1/2, and sine pi over 3 is square root of 3 over 2. So we find the point. And next part, if they provide us the theta equals 60 degrees, so the point is cosine 60, sine 60. So this is a point we can find. And if theta is 45 degrees, cosine 45 degrees, sine 45 degrees, they are here. You see the value. And the theta equals 30, so cosine 30, sine 30. They provide you the value there. For the unit circle, this is a unit circle. Most students, they said they spend a lot of time on memorizing this. Actually, you don't need to spend a lot of time. Just memorize that. For example, in the first quadrant, this is first, second, third, and the fourth. fourth quadrant. In the first quadrant, we know the angle from here to here is pi over 6, or that's 30 degrees. And the point is cosine pi over 6, or cosine 30 degrees. Sine pi over 6. So they are here, shows you that. And this one is cosine pi over 4. Cosine pi over 4, sine pi over 4. Cosine 60 degrees, sine 60 degrees. So right now we know 3 specific points here, and this is in the first quadrant. We have learned in the first quadrant, the x, y value, they are all positive. In the second quadrant, that's negative, positive. In the third quadrant, negative. In the fourth quadrant, that's plus, minus, positive and negative. So we learned the reference angle. So the angle between the terminal side and the x-axis, this is the reference angle. So this one, and this one has the same terminal angle, that is 30 degrees, or pi over 6. So this one and this one, they are the same. What's the difference? Only the sign different, because we just follow this. The x value in the second quadrant is negative. Just put a negative sign here. And let's see another example. This line, or this terminal side, has the angle is 45, and this one has the same reference angle with this one, this line. This is 45. That means the value here and the value here, they are the same. Only difference is the sign in front of the x. How about 45? The reference is 45. And this one, they have the same terminal side, 45 and 45. So here they are the same, which is square root of 2 over 2, square root of over 2. The only difference is the x value in the fourth quadrant is negative. I just put a negative sign here. So for you, you just memorize 3 special points, and then reference angle. Then it will be very easy for you to memorize the special points in other 3 quadrant. Just the sign difference. Okay, let's move on to next part. See the example. Here is the example. T equals 5 pi over 3. So find the others. Find the 6 trig functions. First, I want to find where is this angle. So T is 5 pi over 3. We have learned this is pi over 2, pi. 3 pi over 2, 0 to pi. That's a positive angle. So going to this direction. Going to this direction. This is pi. 5 pi over 3, so it's here because it's greater than 3 pi over 2 and less than 2 pi. What's the reference angle in the fourth quadrant? That's 2 pi subtract 5 pi over 3. And 2 pi is 6 pi over 3. 6 pi over 3 subtract 5 pi over 3 is pi over 3. That means the reference angle is pi over 3 for cosine pi over 3 and sine pi over 3. What are they? This is 1/2. This is square root of 3 over 2, and they are in the fourth quadrant, so the y value must be negative. So this is the way we find the point. When we have the point, we know the first one is x, second one is y. So sine t or sine 5 pi over 3 equals y's value, that's square root of 3 over 2. And the cosine t, that's x value, that's 1/2. And the tangent t, that's y over x. So use this one divided by this. We have negative square root of 3. And for the cosecant, secant, and cotangent, just find the reciprocal of this, this, and this. So we found 6. We can find the 6 trig functions. Okay, let's move on. So you can pause the video and practice by yourself. They give us the t equals negative 5 pi over 4. So I'm gonna to find where is negative 5 pi over 4. So when I see this, I feel this angle, I don't like this kind of angle. So I can split it into 2 parts. One part is pi. Another part is pi over 4. So negative pi subtract pi over 4 equals negative 5 pi over 4. So we are going to the negative direction. I mean, the clockwise direction to find the negative angle. This is pi over 2, negative pi, negative 3 pi over 2. When I got here is negative pi, I need to continue to go pi over 4. So it should be here. That's the negative 5 pi over 4. So what's the reference angle? Reference angle is pi RF, pi over 4. So the point here is cosine 5 pi over 4, sine pi over 4. And decide what's the sign for that. The x in the second quadrant is negative. The y is positive. That means we have negative square root of 2 over 2 and square root of 2 over 2. Right now we have the x value and y's value. So cosine t, or I'd say cosine negative 5 pi over 4 equals x value is negative square root of 2 over 2. Sine negative 5 pi over 4 equals square root of 2 over 2. Tangent. Tangent t equals this. This is sine, or this is y's value, this x value, equals y over x. That's negative 1. And cosecant equals the reciprocal of sine. That's 1 over y. That's square root of 2. Secant t equals 1 over x. That's negative square root of 2. How about the cotangent? Cotangent reciprocal of negative 1. That's negative 1. Okay, we'll find all 6 trig functions. Okay, let's see part 3. Identify the domains of the trigonometric function. What's the meaning of domain? For example, if I have a function f of x equals 1 over x subtract 2, 1 over x minus 2. Domain means I x can be what kind of value. So if x, we choose a value of x, make the function f of x undefined. So this is not the domain of x. We can't choose that. So what kind of condition can make this function undefined? That means if x equals 2, so the function is 1 over 2 subtract 2, that's 1 over 0. So 1 over 0 is undefined. So I can't have x equals 2. So x can be any real number, but x cannot be equal to 2. So x can be negative infinity to 2, union to infinity. That means this is a domain of x, can choose any number, but only cannot choose 2. That's the domain of a function. Let's see for the trig function. We have learned that if we have a f of t equals tangent t, this is tangent t. Tangent t equals y over x. What condition can make this function undefined? That means x equals 0. So the domain of this function cannot let the x equal 0. That means what kind of condition for the t can make the x value x equals 0? We can't choose that. So when t equals pi over 2, the x is 0. So it's undefined for tangent t here. And for the secant t equals 1 over x. So secant t also is not defined at the t equals pi over 2. And for cotangent t, secant t is the same because the denominator has the y's value. When t equals pi, it will make the y's value equal 0. Cotangent t and cosecant t are undefined. That means cotangent t and secant t is undefined at this point and this point because they all have the y's value equals 0. And tangent secant t, they are undefined in these 2 points. So let's see the summary of the summary table. What kind of condition the function is undefined? For sine and cosine, you see sine, cosine, sine t equals y, cosine t equals x. So there's no denominator. That means t can choose all real numbers. So no restrictions. But for tangent t equals y over x. That means if the t make the x equal 0, that's undefined. So t cannot choose, we can't choose 2n plus 1 times pi over 2. So this expression means the point here, here, and here. That means if t is not equal to this expression, that means exclude all the multiples of pi over 2. For the secant is the same, but because secant equals 1 over x, or I say the reciprocal of cosine t. So it's same like the tangent. So we can't choose this. For the cotangent t is undefined in this 2 points. So t is not equal to n pi because here is 0, here is pi, and go back here, that's 2 pi. Go back here is 3 pi. 4 pi. That means n pi. So if the t equals n pi, that make the cotangent undefined. And for the cosecant, it's the same. We can't choose the t equals n pi because cosecant equals sine, reciprocal of sine t. That's 1 over y. So y's value equals 0. Make this undefined. Okay, let's move on to next part. Okay, the first example, tangent 3 pi over 2. Let's find the angle on the unit circle. The unit circle is here. So 3 pi over 2 is here. The point here is 0, -1. This is x value, y's value. And we have learned that tangent t, or tangent 3 pi over 2 equals y over x. Oh, x is 0. It's -1 over 0. So there is 0 in the bottom. That means undefined. So this one is undefined. There's no this kind of value for tangent 3 pi over 2. Okay, next one, secant negative 180 degrees. So find the point. Negative 180 is here because we're going in this direction. Got here is negative 180. And the point here is negative 10. This is x value, y's value. And secant equals negative 180 degree equals 1 over cosine negative 180 degrees. So cosine 180 degree, that's x, 1 over -1. That's -1. So the answer for this is -1. Part 4, apply the period and property of trig functions. Define of a periodic function. A function of x is periodic if f of t plus p equals f of t for some constant p. The smallest positive value p for which f is periodic is called the period of f. That means if I have a function f of t, and then for the t part, I add a p, and it has the same value as the previous function f of t. That means this is a periodic function, and the value p is the period. P must be the smallest positive value. That make this equation equal. So let's see the table here. For the sine function, for example, the period for the sine function is 2 pi. That means sine of t plus 2 pi equals sine t. Also sine t plus n times 2 pi. It still equals sine t. It's very similar like the coterminal angle, because we have learned if t plus 2 pi, the coterminal side is still the same as the t. So if some student ask, how about the subtraction sine t minus n times 2 pi? Yes, Since 2 pi is a period of a sine function, sine t function, so this one also equals sine of t. Okay, let's see. The sine function's period is 2 pi, which is 360 degree. That means sine of t plus 2 pi equals sine t. Or I can say sine theta plus 360 degrees equals sine theta. For cosine, the period is 2 pi. Cosecant is 2 pi. Secant is 2 pi. Only these two, tangent and cotangent, their period is pi. That means tangent t plus pi equals tangent t. Cotangent t plus pi equals cotangent t. Let's see the example. The first example, sine negative 11 pi over 6, because this is a negative angle. We don't like to compute negative angle. We can make it into a positive, small positive angle. So this one equals sine negative 11 pi over 6. If I add one period, it's still equal this. So let's see, what can we find? 2 pi is 12 pi over 6. So the result of this is pi over 6. That's 1/2. Next one, tangent to 225 degrees. This one is big angle, so we can subtract one period for tangent. Tangent one period is pi. That's 180 degrees. This one equals tangent 225 degrees. Subtract 180 degrees equals tangent 45. 45 is easier to calculate. It's 1. Next one, secant 9 pi over 2. This is a big angle. And also I have learned that secant equals cosine 9 pi over 2. Then 1 over cosine. I can subtract 2 times 2 pi, 2 period for the cosine. So 9 pi over 2 subtract 4 pi equals 4 pi is 8 pi over 2. So this one equals cosine pi over 2. Cosine pi over 2 is 0. 1 over 0, that's undefined. So the answer for this one is undefined. Next one, even and odd function. Even function is f of negative x equals f of x. Odd function is f of negative x equals negative f of x. Sometimes it's confusing. Just for example, f of x equals x squared. So is this function is odd function or even function? We just plug in negative x inside and compute it. So plug it in negative x in the function, we have negative x squared. So negative x squared equals x squared. This equals f of x. That means f of negative x equals f of x. Satisfied the first condition. This is even. For the 6 trig functions, only the cosine x and its cofunction, the secant x, that's equals 1 over cosine x, are even function. Only these two are even. That means cosine x, cosine negative x equals cosine x. Even I have a negative x here, but the result is still equals cosine x. And the secant x, or I say negative x, we have learned this is a reciprocal of cosine x. So equals cosine negative x. And we already proved that we have learned that cosine is even. So this one equals 1 over cosine x. Cosine x equals 1 over cosine x equals secant x. That means secant x, negative x, equals secant x. So cosine x and secant x, they are all even. And sine x, cosecant x, tangent x, cotangent x, they are odd. For odds. That means sine negative x equals negative sine x. Cosecant negative x equals negative sorry. It disappeared. Maybe you just go back to see that those four trig functions, they are all odd functions, and only cosine and secant x, they are even function. Okay, let's see the table here that shows you that a sine. I'm sorry. Come back. What should I do? So let's use the whiteboard here. I think it's still recording. Yeah, it's still recording. So let's write something here. All the functions, they are sine x, secant x, tangent x, cotangent x, and even function cosine x, secant x. Let me see. Example. Let's see the example. I have 4 times cosine x plus cosine negative x. And we know this is even. So 4 times cosine x plus this one is cosine x. This one is 5 cosine x. Another example, tangent negative 3t minus tangent 3t plus pi. We know tangent is odd function, so this one equals negative tangent 3t. Subtract here 3t plus pi, because we know the period for tangent is pi. That means this one equals tangent 3t. So negative tangent 3t minus tangent 3t is negative 2 tangent 3t. Okay, let's see the let me see the word is still not working. Right now it's working. Let me share my screen. Okay. Let's see the word file. Expressing a trig functions in terms of another trigonometric function. Actually, we learned this before. We use the identities to express this. But if they give us example for a given real number t, express sine t in the term of cosine t, we have learned sine t squared plus cosine t squared equals 1. So if we want to have sine t equals what kind of expression, and the expression has cosine t, we just move or subtract cosine t squared both sides. Sine t squared equals 1 minus cosine t squared, and then take the square root of both sides. Square root of this sine square root of t 1 minus cosine square root of t, and then sine t equals plus or minus square root of 1 minus cosine square root of t. This is the way we use this identity to find. And we also learned that if in the unit circle, if I have a unit circle and they gave us the t can be the angle, or t is the arc length. And on the unit circle, all the x, y satisfied x squared plus y squared equals 1. And x is cosine t squared, and y is sine t squared. This one equals 1. And it's same like we have proved here. So this one can be written like isolate the sine square root of t equals 1 minus cosine square root of t, and sine t equals plus or minus square root of 1 minus cosine squared t. So you can use either way. The unit circle one or the identity one also have the same result. Here is how does the unit circle one works. Next one, this one appears in your homework. The example is in a small coastal town, the monthly revenue received from the tourist rises and falls throughout the year. The tourist revenue peaks during the months when the town holds the seafood cooking competitions. The function they gave us is this. represents the monthly revenue f of theta in tens of thousands of dollars. What's the meaning of this? This expression represents the monthly revenue, and we want to know, is this function is the periodic function? That means f of theta plus p, is that equal f of theta? So let's see. I just plug in the number for theta. For theta equals 0, and plug it in the calculator, or plug it in the expression here. We got 5.1 times cosine pi over 3 times 0 plus 12.5. We got this one, this value. I plug in the 1 in the expression. I got this value, 2, 3, 4, 5. And I see the first 7.6 appears here, and 1 is my second 11.6. When theta is 6, the function give us the value is 17.6. 17.6. And I'm gonna see the number after 17.6 is the same. I use this color and this color. Oh, they are the same. And next one, 10, they're the same. 7.4, 7.4, same. 10, the same. How about the number after that? So 15.1, 15.1. That means this is the periodic expression, because after I insert the number 0, 1, 2, 3, 4 to 11, and they provide us periodic values. You see here the same, and the following number, they are the same. So this is a periodic functions, and when the revenue appears the peak, that means the most value for the function is here and here. If the question asks you when theta equals 0 represent February, that means this is February, and then March, April, May,